A virtual machine is software-based emulation of physical computer. It runs an operating system and applications just like a physical computer, but it is hosted on a physical machine known as a host or a hypervisor and is isolated from the underlying hardware. What is a virtual machine? A virtual machine uses software to simulate a physical computer, allowing multiple virtual systems with their own operating system and applications to run on a single physical systems. Key components of virtual machines are hypervisor, software that create and manage virtual machines. Example Microsoft Hyper-V, VMware, KVM, and VirtualBox. Guest operating system. The operating system installed inside the virtual machine like Windows or Linux. The operating system running on the physical machine on which we have created virtual machines. And virtual resources. VMs are allocated virtual CPU, memory, disk, and network interfaces from the host machine. Why virtual machines are required? Number one, cost efficiency. Reduces the need for physical servers, saving hardware and energy cost. Number two, resource optimization. Better utilization of hardware by running multiple virtual machines on one server. Isolation and security. Each virtual machine run independently, preventing one from affecting others. Scalability and flexibility. We can easily create, clone, backup, or move virtual machines between servers or data centers. Disaster recovery. We can take the snapshots and backup to make virtual machines easy to restore. Testing and development. We can also use the virtual machines for developer can test applications on multiple operating system platforms without needing separate hardware. There are different types of virtual machines available. It can be classified based on purpose and environment. System virtual machine. These simulate an entire physical machine and allow you to run a full operating system. It can be used in server consolidation, application testing, and in a multi-OS environment. Examples, Windows virtual machines running on a Linux host and Linux virtual machines running on a Azure or on AWS EC2. Process virtual machines. These are designed to run a single application or process. They abstract the environment for that app only. We can use these virtual machines to run Java application on any platform, emulate old environments for legacy apps. Examples, Java virtual machines, .NET Common Language Runtime. VM types by purpose in real world scenarios. We can differentiate the VM types by purpose in real world scenario. Development, for the development and testing purpose, virtual machines. For coding, testing, debugging across operating system versions, often used with tools like Docker or Vagrant. Server VMs. We use server VMs to host websites, databases, and file services. It is common in cloud like Azure VM, AWS EC2, and GCP Compute Engine. Desktop VMs. Desktop VMs used for remote work, running application in isolated environment. Example, a Windows 11 virtual machine on a Mac operating system using VMware Fusion. Cloud virtual machines. Cloud virtual machine offered by cloud platform for scalable computing needs. It can be auto-scaled and load balanced. Application VMs. Containers can also be seen as a lightweight virtual machines. These containers run on isolated application with minimal overhead. Common virtual machine platform and hypervisor. For the desktop, we can use VMware, Workstation, VirtualBox, and Parallels. For the server, VMware, XE, Microsoft Hyper-V, and KVM. For the cloud, Azure Virtual Machine, AWS EC2, Google Cloud VMs. And for the containers, we can use the Docker, Kubernetes for orchestration. In conclusion, if we see, virtual machine provide a flexible, secure, and efficient way to use computing resources, whether for the software testing, running multiple operating system environments, hosting applications, or powering cloud services. VMs are foundation of modern IT infrastructure.